Good evening to all of you. Myself Anjali Dikshit, and I'll be your TA for this solving session for the course of Earthquake Geology, a tool for seismic hazard assessment, whose course instructor is Professor Javed and Malik. Let's move to the our first problem, which is I hope you all can see my screen. So the problem is a location where an earthquake originate is termed as. So there are few options. So to answer this problem, I think with the help of the simple diagram would be nice to understand. So suppose this is our earth surface, and this is the fault plane, and for example, due to the movement across these two sorry, due to the movement across this fault, suppose at a place of this, the energy got released, and and the line, if we draw a line just perpendicular to that particular point, we got some another location. And suppose our recording station, or the place where seismogram has installed, is over here. So if I name all the points that I have marked, for example this point, so the point where the earthquake occurred is called as a hypocenter. And if you just extrapolate this point in a vertical direction up to the surface, so this point of cross section, we called it as a epicenter. And the distance from this epicentral point up to this recording station, that is up to here, is called as epicentral distance. And as I mentioned earlier, this is our fault plane at which earthquake initiated, or where the energy got released. So this is the, I think this picture will help you to answer this question now correctly. Now let's move to the second question. So the second question is, what is the fastest kind of seismic wave, and consequently the first time to arrive at a seismic station and can move through solid rock and fluids like water or liquid layers of the earth? So I thought of before answering this question, to explain you few concepts relating to the wave propagation. So let's move into those concepts. So in general, we have a four kind of seismic waves. Under that, we have two broader categories. First is the body wave that you can see over here. So as its name suggests, body wave, so it travels through the body of the earth. And under that category, we have two major waves. First is the P wave, as you can see, and second one is the S wave. Now the property of P wave is, first the P stand for the primary or the pressure wave. So since they are the pressure wave, their movement is like push and pull kind of movement they show. And also these kind of waves are also called as a longitudinal waves, because their motion is parallel to the direction of propagation of the wave. So the particle motion is in the direction of the propagation of the wave. On contrary, S waves, in S wave, the S comes from the shear or shake waves, or the secondary. And the particle movement for this kind of waves is perpendicular to the direction of the wave. So these are the body waves. Now let's move to the second category, that is the surface waves. So as it's again the name suggests, surface waves, so they travel along the surface, and under that we have two major waves, the Rayleigh waves and the Love waves. And here you can see the movement of the particles, that for the case of Rayleigh wave, it has a retrograding elliptical movement, and for the Love wave it has a horizontal shaking movement. Now if we'll see the velocity of all the four waves, so this is the final sorry so this is the final expression that is marked in this box. So the fastest wave, you can see it's the Vp, that is the p wave velocity, and that's why this name came from primary waves. And after that we have a secondary wave, then Love wave and the Rayleigh wave. So I hope now you can answer this question very well, and yeah, I think this will help you to answer the questions. So thank you all.